It's Brad's Laboratory.
You can buy surge suppressors that go between the power pedestal and your RV, but at $280, this surge suppressor is a little pricey. However, it is well worth it for the off chance a lightning strike occurs and sends a surge through the shore power pedestal into your RV. After thinking about buying this unit for a while, I decided it would be better to build my own. I wanted to incorporate it into the RV so it was hidden and out of the way. I first came up with the schematic design incorporating stacked metal oxide varistors and a power filtration unit. Metal oxide varistor is usually shorted to MOV. 3 MOVs to each leg of the power, hot, neutral, and ground will provide surge suppression. The filter is a sealed unit and provides electromagnetic interference protection. A common mode filter marked L provides noise rejection. The box is a beautiful cast project box. While a little expensive, it is also strong and will resist any fires and explosions on the off chance of a lightning strike and 1.21 gigawatts of power flowing through it. I also found a terminal block that was rated at 60 amps and used it for terminating the input wires and a spot to attach the MOVs. I built the MOVs into modules, one module of 3 MOVs for each power leg. I soldered the MOV leads into fork terminals spaced to attach to the barrier strip. On one of the MOV assemblies I was building, I needed to extend the legs to allow for it to stretch between the ground and hot terminal blocks. I accomplished this by wrapping a thin piece of copper wire around the leads and a thick 12 gauge piece of wire. Once I was happy with the assemblies, I heat shrunk the legs and then I added liquid electrical tape onto them to prevent any spark gaps. All wiring in the box is 10 gauge to handle the 30 amps, with a pigtail of 10 gauge Romex to feed the breaker box. I considered some indicators in this build to show that the surge suppressors were still active or to show that there were line neutral reverse wires or a missing ground, but I ultimately decided to follow the KISS principle of engineering, that is, to keep it simple, stupid. I bought an assortment of nuts, bolts, washers, and lock washers from Lowe's. I will have a list of these in the description. I will also have Amazon links for the rest of the parts in the description. I start by marking and drilling the holes needed for mounting the parts in the box, including a hole for the ground stud. I used a flathead screws to keep the outside of the box as clean as possible. The cable entrance and exit holes are drilled with a step drill, and cable clamps are installed. Next, I assemble and wire up the electronics using 10 gauge wire. The barrier strip is installed using 1.5 inch number 6 screws, flat washers, split lock washers, and nuts. The ground wire is attached to the filter. The MOV assemblies are removed to allow the wire to be formed to the barrier strip in a more easy fashion. A ground lug is installed in the box with a star washer between the case and the terminals. It is important that the case is well grounded, so if a hot wire gets loose, it will ground out and pop the upstream circuit breaker. In this case, it will be the circuit breaker on the shore power pedestal. Once all the wires are formed and fit into place, the filter can be installed with 1/2 inch number 8 screws, washers, split locks, and nuts. There is much discussion in the mechanical engineering community about this stack up of hardware, but it is what I prefer, and from my early years of working on farm equipment through my more formative years of working on military equipment, it has not let me down. Now the MOV assemblies can be reinstalled. I snaked the longer MOV assembly under the wiring that feeds the filter and the other two on top of that wiring. And the one side of the barrier strip can be tightened down and finished. Before the ground stud can be finished, the pigtail of 10 gauge Romex needs to be brought in and the ground needs to be connected to it. The ground stud gets the same hardware stack of flat washer, split lock, and nut. Using tie wraps, I bundled the neutral and ground wires together at the bottom of the case to keep them far from the hot wires. The hot and neutral wires get terminated to the load side of the filter with the hardware that came with the filter. I also went through off camera and dabbed silicone onto all the nuts in order to be triple sure they would not come loose. Next, I marked the neutral, hot, and ground on the input side of the barrier strip. Now it's time for a quick sanity check that all is well. With a temporary power cord, I check that I have 120 volts between hot and neutral on the output pigtail, and again between hot and ground. All is good. I am careful to disconnect both the AC shore power and DC battery power to the RV before I start working. I ran an extension cord into the RV to power my work light only. I pull the power converter assembly out and take the shore power input wires loose from the breaker. I struggled a little with the plastic clamps that the RV manufacturer used to clamp the wires into the power converter box. I wound up pulling it out and then destroying it to get the wires free. I installed a new metal clamp that worked better. Once the new clamp was installed, I easily installed the pigtail from the new surge suppressor and the other existing wire that was to the same wire clamp. Now with the power converter wiring all back together, I brought the wire that used to go to the converter into the surge suppressor and attached it to the input side of the terminal block. The cover goes on to the surge suppressor with the screws that came with the box, and laying sideways I stuff the box into the hole and attach it with screws to the side wall of the area under the refrigerator. The power converter goes back in the hole and the cover goes back on it, completing the work. Plugging the AC and DC power back into the RV, everything is now surge protected. If you like this video, please subscribe. If you have a question, leave a comment and I will be happy to answer.
It's Brad's laboratory. It's kinda crazy and a little bit weird, but it's gonna be awesome sauce, cause it's Brad's laboratory. It's Brad's laboratory. So grab a spot, you'll learn a lot, maybe even how to build a robot, cause it's Brad's laboratory.